Okay, guys, we talked a little bit about the front, but we're going to do the front in class. So I actually want you to take notes on the back. So we're going to find out how to do a significance test in class, right? The basics, we know that there's more than one way to do a statistics, different things we're going to need in statistics, right? So learning target 1, this is how this sets up in most of science classes or research classes, so chemistry, biology, AP research. We set out to have a null hypothesis. That's this H sub O, which is either our proportion or our mu, right? And we call that our null hypothesis. That's some value we believe is the truth. And again, we are either asking a yes or no question or we're measuring something. So an example is maybe we think that right now 40% of Americans think that Trump really won the election. This is what we believe is the true proportion of people in the United States that believe that. That's P, a number that describes the population. What would be an example of mu? Well, anything that I might measure. So a typical average of your temperature maybe is 98.6. That should be the average temperature of an adult, right? 98.6. So that's our null. Let's say you have a sneaky suspicion that it's something other than that. So that's called an alternate hypothesis, right? So we call that H sub A. So the A stands for alternate. The null stands for like O for your original thought. So maybe you think that it's something greater than, right? Maybe you think that there's less than 40% that are think Trump presidency was stolen. Maybe you think it's something greater than, less than that. Or maybe you think it's just something not equal to that. It's just not 40%. Maybe it's less, maybe it's more, okay? So you're going to come up with one of those 3 alternate hypotheses, and you're going to decide to do a study, and you'll come to me and say, hey, Ms. Kruzmark, will you be my AP stats or AP research advisor on this topic I'm studying, all right? You also might have an alternate hypothesis about, hey, I'm in the medical field and everyone that I take their temperature of and I make sure that it's a good thermometer, their average temperature is not 98.6. So I have reason to believe it's something other than that. Again, maybe you think it's something less than that or more than that or just not equal to that. You're just like, I just don't think it's 98.6. I've now taken the temperature of hundreds of people. It's never 98.6 or close to that. I think it's something other than that. That's called your null value, okay? This is the most common use of statistics. It's actually not the confidence interval, but we did the confidence interval to kind of approximate what that true value would be, okay? So we've done this before. Can we come up with a p-value, which is the probability of getting that outcome? So we call that interpreting our p-value. All right, so we always have to assume that H sub O is true. Of course, you should assume that the news is right, that 40% of it, they reported that 40% of people think Trump really won the election. Or, we look into the book Grey's Anatomy and they said 98.6 is really the average temperature of an adult, right? We first must start with assuming that H sub O is true, right? And then we say what that value is, whatever that is, right? So whatever H sub value is, assuming that it's true, assuming that the average temperature of an adult is 98.6, or assuming that the nationwide average of adults that think Trump should have won was 40%, then what we're saying is when we get a p-value, we're saying that there is a blank probability of getting the observation we got, the observed result. Oh boy, what happened? or more extreme. And we've done this a couple different times during the school year. So we're kind of building on that purely by chance. So what could be our values? Again, if we use the examples before, assuming it is 40%, there's a blank percent probability. So this is our p-value, whatever p-value our calculator creates. All right. Now for learning target number 3, we'll again build on these concepts. We have to conclude. So what kind of conclusion can we come to? Either your p-value, and we've talked about this before. Usually we set our p-value that if our p-value is less than 0.05 or whatever we set it to. So we'll notice some applications where we set it to something lower than 0.05 and we call that alpha because that number could change. So we say if the p-value is less than 0.05, then we're going to reject the null. And we say that if the p-value is greater than or equal to 0.05, which could be alpha. We don't know. We're going to set it to 0.05, but they could set alpha at 2% or 1%. Then we fail to reject the null. And instead of writing the word null, N-U-L-L, I'm writing the word H sub O, a capital H and a subscript 0. So what does this mean? We've actually done this on Khan Academy before, and we're building on that. So in conclusion, I'm saying that because my p-value is either less than or greater than alpha, I've got to determine that. You either do or do not have convincing evidence for H sub A. That's your sneaky suspicion. You're trying to prove whatever those sneaky suspicions are, right? In context. So maybe you have a sneaky suspicion that it's something greater than 98.6 when I take somebody's temperature. Or maybe you have a sneaky suspicion like, I don't think that many people are supporting Trump. That's just crazy talk. So I'm going to take another survey and I'm going to try to debunk that idea that 40% of people think Trump really won the election. Okay? So we're not going to, don't worry, we're not going to take another badge anytime soon, right? We just took 2 badges, but we're learning how to take another badge. Okay, so we see here that we're going to learn how to state, we're going to learn how to conclude, and maybe the plan's going to be something similar to that. Okay, so we're going to just kind of go through the basics here. So we look at a question, it says, factinate.com claims that 84% of teenagers think highly of their mothers. To investigate the claim, the school psychologist selects a random sample of 150 teenagers and finds that 135 think highly of their mothers. Does this data provide convincing evidence that the true proportion of teens who think that highly of their mothers is greater than 0.04? Okay, so did they collect some amount of evidence that it's greater? Let's take a look. Let's just do a simple, quick calculation. They took a sample, so I write p hat. What is 135 over 150? Okay, what did they get? So they might have a sneaky suspicion. 135 over, oh boy, lots of commercials here. 135 divided by 150 is 0.9. Okay, so they actually got 90%, which is greater than that, but is that purely by chance? Again, what we're saying is if the truth really was 84%, then, part of the time you might be a little higher than that, part of the time a little lower. So is this sample just based purely on chance and the truth really is 84%? We can actually use the calculator to calculate an outcome like 0.90 or greater or more extreme of a probability. And then if that number is less than 0.05, we're going to go, oh, okay, we do have convincing evidence from the sample that the true proportion is maybe greater, okay? Because we have some evidence it's greater. How do we go about stating these hypotheses? Okay, so the first thing we do is we state our ho and our ha, the ho and the ha. Our H sub O, we're told that this is 84%. Okay, we're going to leave it at that. We accept that as the truth. That's the claim. Now, we have reason to believe it's something greater than that, both because we have a hunch and we have a sample that it's something greater than that. Okay? That's our state. Now, just like last chapter, I have to define what P is. So if I'm going to use the variable P, I have to tell you what P is. We are trying to gain additional information about P. And what is P? The true proportion of teens who think highly of their mothers. Okay, right? I'm copying it right out of the problem. Okay. Now, it says school psychologists performed the significant test and obtained a p-value. Ooh, I likey this p-value. The reason why I like it is that it's less than 0.05, which means I can reject the null. What does that mean? It means because the p-value is less, we do have convincing evidence for H sub A. We do have convincing evidence that the true proportion of teens who think highly of their mothers is greater. We have evidence of that because it was such a rare outcome. And in fact, it should be relatively surprising if the truth was in fact 84% to get a number that high, especially from such a large number of people. Okay, that's a very rare outcome. So we're going to explain what it would mean for the null hypothesis to be true. If the null hypothesis is true, so we're saying if this is true, what does that mean? It means 84% of teens think highly of their mothers. And essentially, the sample, we just took a single sample size of 150, the sample proportion, which was 0.9, happened purely by chance. And essentially, that's what our calculator is telling us. That absolutely could happen by chance, and it would happen by chance about 2.25% of the time. That's a pretty rare outcome. So how do we interpret a p-value? When we get this p-value, we say, and we notice our notes up top say the same thing, assuming that H sub O is true, which is that P is equal to 0.8, yeah? Then essentially we're saying our p-value is telling us there is a 0.0225 probability of getting a sample proportion of, right, what was that? 135 out of 150 or greater purely by chance. So I'm learning a new script. We'll continue to practice the script. Today is the first day we're doing the script. We don't have to do the script tomorrow. We'll keep practicing. But what conclusion will we make? Okay, so we're doing a significance test. The conclusion we can make at this level is that this number is less than that. So I know from my script, because we have a p-value of less, then we do have convincing evidence for H sub A. What is H sub A? that the true proportion of teens is something greater than 0.84 because we have evidence of that, and that evidence is a very rare outcome. Okay, we're going to write that out because this number is less than that number, which is what we're going to set alpha. Then we can say we do have convincing evidence that the true proportion, and you're like, wait a minute, am I just copying these words? You bet your biscuits. That's it. We do have convincing evidence that the true proportion of teens who think highly of their mothers is greater than point. I'm just copying that last sentence. And that is just like we did in the last test. We do have convincing evidence that the true proportion of teens who thinks highly of their mothers is greater than 0.84. So therefore, we have to have an outcome. So I made a conclusion, but I need an outcome. We reject the null hypothesis. We reject the null hypothesis. That's it, guys. Thanks for joining us. See you next time.